Hey everybody, I wanted to go over some multiple choice questions, and so here are the multiple choice questions from Exam 1 from the fall of 2016 from the class that I teach at RCBC, Rowan College of Burlington County. So I think there are 6 multiple choice questions, and we'll get over them. Okay, so let me switch to this here. Okay, so the first question here, question number 1, okay, it says, which of the following changes to the system in the systems at equilibrium would cause the concentration of H2O increase? So I'm going to draw a little arrow here. Okay, so that means one of 2 things need to happen. That means the reaction needs to shift right, or we have to decrease the heat, which is still going to cause the reaction to shift right. So I guess there's really just one way. We just have to make sure that whatever is happening, the reaction is going to shift right. Okay, so let's see what's going on. The volume of the system was decreased at constant temperature. So when we do this, this is really just looking at moles of gas. Okay, so how many moles of gas do we have here? We have 7. Here we have 8. And so when we decrease, that's going to cause this to shift left because it's going to shift to the side with more moles of gas. Okay, so that's not right. Okay. Okay, so the next thing that we could look at, okay, let's look at the temperature of the system was increased at constant volume. Well, if it increases, that means it's going to shift left, and we don't want that. So now if NH3 was removed from the system, now again that's going to shift this way because there's a hole here that's going to want to be filled. So that's not right. Now if N2 was removed from the system, now the reaction is going to shift this way to fill that void, to fill that deficit stress, and so that's a right shift. So far that's the one that works. And now what if we, and let me get rid of this here, what if we do this last one? O2 is removed from the system. If O2 is removed, that means the reaction is going to shift this way to fill that void. That's another left shift, so the answer is D. Okay. So now this next one here, let's take a look at it. Okay, I'm going to get rid of my ink layer. I'm going to scroll down. Okay. And so maybe we can do these next 2 here. Okay, if I can get them all on the same thing. Okay, let me fix my calculator. Okay, so consider the reaction at 1,000 degrees. If we consider that reaction at 1,000 degrees, this is our Kc, and it says what is the value of Kc for the reaction below. And so now what we want to do is, this is the question that answers the related rates. So related rates here, this means that this thing is related to this guy, and so all we have to know is what happens to this reaction to get that reaction equal to it. So this we're going to have to flip, okay, that's kind of a pun, flip it here, because now these 2 things are the products, and here they're the reactants, and we have to multiply by 2. And so when we flip and multiply by 2, that means we do the reciprocal and square it. So if we do the reciprocal and square it, so that's going to be 49 squared, and then 1 divided by that, okay, is 4.2 times 10 to the 4th, okay, and so to the negative 4. Why isn't it 4.1649, all that stuff? This is because we have to worry about significant figures. This only has 2, so this only has 2. Okay, so that's question number 2. Let's scroll down. I tried to do it, but it's not going to work. Let's look at question number 3. Okay, so it says here's a proposed mechanism for this reaction, and it says what are the overall products of the reaction. So what we should do is we should cancel out the things that are found on both sides of the equation. So here's an NO and here's an NO, so those cancel out. Okay, and then let's see, here's an NO2 and here's an NO2. and those cancel out. Okay, so now what are the only two products left over? Well, the only two products that are left over are CO2 and O2. So that's your answer for that one. Okay, these two things are what we call intermediates, or I guess this is maybe even a catalyst, because it's starting in the reaction, it's added, but then it's regenerated at the end, and now this molecule can go back and start to precipitate another reaction happening. Okay, let's scroll down. We got 3 more of these to worry about. Okay, so this one is a little tricky. Okay, so it says below mechanism is proposed for this. Here's the mechanism, and this is pretty well studied, and this is probably the way that this goes. Okay, so remember that the rate law has to be consistent with the slow step. Okay, and so in this case, the rate law is going to be consistent with these two things. So we're going to have R equals K, and then the concentration of Cl times the concentration of CH3. But the problem is Cl is not one of the reactants. So we have to find out where that is produced, which is right here, and then we have to see what's going on. And so notice that for every one of these, 2 of those is produced. So that means that for every one of these, we only need a half of a Cl2. Okay, so that means that this is a half a Cl2, and when we are doing that in kinetics, the Cl2, the stoichiometry for the slow step becomes the power. Okay, so that is the answer to that question. Oops, I keep hitting my, I'm going to move back my thing here. I need a bigger kitchen table, I think. Okay, so now the next one. Here, let's scroll down. Oh, look, this one I can get in the thing, and they're both just regular old knowledge problems. Okay, it says when the concentration of H plus is doubled for the reaction, there's no change in the rate. So H plus is here. So that if there's no change in the rate, that means that H plus is not in the rate law. If it weren't in the rate law, because it's not in the rate law, nothing happens to the rate of the reaction. Okay? And so if it were in the rate law, by changing the concentration in any way, that would change the reaction rate. So we have to find something that matches what this is. So let's see, H plus is a spectator ion. No, just because it's a spectator ion, spectator ions wouldn't be written in the overall reaction. Okay, the rate determining step does not involve H plus. That sounds good. Okay, the mechanism does not involve H plus. Well, I think it has to involve H plus because all the steps in the mechanism have to total what the overall reaction is. H plus is a catalyst. Well, catalysts aren't listed in the overall reaction. Okay, so that's not right, and then this isn't right, and then it says the rate law is first order with respect to H. Well, because the concentration of H doesn't change the reaction rate, that means it can't be first order in H. It means that H is not part of the rate determining step. So the answer is there is B. Okay, and then the last one here, question number 6 says, for the following reaction, the rate law, blah, 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 and it says, which of the following statements is true? Okay, so these two questions are kind of related, because what we're saying is that CO is added to the mixture. Okay, and so if CO is added to the mixture, notice what happens. The rate will stay the same, okay? Because the rate is only dependent on the concentration of NO, not on CO, or NO2, okay? So we have to find the one that's first of all says that the rate is going to stay the same. Look, there's rate stays the same, and the rate stays the same. Okay, and so now we have to figure out, well, K, we have to know something about K. Well, it says for the following reaction, small amount of reactive, which of the following, well, how does K change? The only way that K changes is if the temperature's changed, and we are not indicating a change in temperature. So since there's no temperature change, okay, that means that K must remain the same, and that one is incorrect. Okay, so your answer here is A. Okay, so that's the 6 multiple choice questions from the fall 2016 exam from Rowan College at Burlington County. Thank you so much for watching.